Welcome to the first of 4 videos on quadratic equations, solving by factoring. Before we can get to that, there's a concept we need called the zero product property. It's really just a fancy math name for something that we've all known since 3rd or 4th grade, but it's worth discussing. Suppose I were to tell you that some number times some other number were equal to 0. Well, it's certainly possible that the first number might be 0, as an example, or maybe the second number is 0, or maybe they're both 0. But definitely, if a number times number is 0, one of them has to be 0. There's no other way. Now this sounds totally obvious to all of us, but I'm giving it a name because we're going to need that idea to solve quadratic equations. By the way, here's a way to state it more formally. And 0 is kind of unique in this regard because it's the only number that has that property. Let me give you a different example. If I told you that a number times another number were equal to, say, 6, would you be able to conclude that one of the numbers were 6? Well, maybe one of the numbers is 6. But maybe one of the numbers isn't 6. Fractions and decimals would work here as well. So the idea, again, 0 is unique in that if a number times the number is 0, obviously one of them has to be 0. All right, keeping that obvious thought in mind with a new name for an obvious thought, let's go on to talk about what a quadratic equation is. A quadratic equation is an equation with a second-degree polynomial in it, basically an equation with an x squared. Now, the simple algebra that you've learned to solve other equations turns out doesn't work well when you have an x squared in an equation. Now, before I show you the correct way to solve this problem, I want to show you a bad idea, but we're going to learn something from this bad idea. Suppose I were to add 40 to both sides of the equation, because if I'm trying to solve for x, I should get the x by itself. Well, there's some logic to that. That would give me this result. And suppose in the goal of trying to get x by itself, suppose I divided both sides by 3. Well, look at the left side of the equation. A little known algebra fact is that if you're dividing two terms by 3, that's the same as dividing each of them by 3. Now here the 3's would cancel, leaving us with the x by itself, but nothing else would cancel. Now nothing I've done here is wrong. This is all mathematically correct, but this is what I call mathematically correct and a terrible idea. I haven't made any math mistakes, but look at the beginning equation and the equation I'm at now. I haven't made this problem any easier. And if algebra is correct and it doesn't lead to a simpler result, then it's useless algebra. The purpose of the beginning of this problem is to show you that not all the algebra tricks that you would use for an equation that doesn't have an x squared, known as a linear equation, those tricks don't necessarily work when there's an x squared in your equation. So of course the obvious question now is, what does work? We're going to solve this equation using factoring. For a moment, let's pretend the equals 0 wasn't there, and just pay attention to this trinomial. This trinomial is factorable, as shown. Side note, there's a video called Factoring Monic Trinomials that I've produced that you can check out to see how to factor monic trinomials like this and even find out what a monic trinomial is. Presumably, if you're watching this video, you've already seen that one, but if that's not the case, you may want to go back and check that one out. Now, if you're comfortable, let's move forward. Let's put back the equals 0 and notice why factoring was such a good idea in this problem. Because by having factored, I can apply the zero product property. Now watch the equation and look at what we have here. We have a number times another number equaling 0. And you may wonder why I called x plus 8 a number. Well, just because we don't know what x is doesn't mean that x plus 8 doesn't represent some number. So since I've got a number times a number equaling 0, the obvious zero product property from elementary school tells us either the first number must be 0 or the second number must be 0. And this gives us a means of splitting our one quadratic equation into two linear equations. And once that's done, each of them is super easy, and we now have the two answers to this problem. By the way, it's worth showing, even though I'm done with the problem, that these two numbers actually do work. As an afterthought, let's take our equation and let's substitute in x equals 5 just to confirm that it is in fact a solution. Putting a 5 where the x's are and doing a little algebra will show me I have a true statement. Hit pause if you want to look through all the details. Otherwise, we'll move forward. So 5's a solution. Let's also confirm that negative 8 is a solution, as it's purporting to be. Taking the equation and substituting negative 8 for x will yield a true statement as well, proving that negative 8 is a solution. If you're the kind who likes to confirm details, then hit pause and do that. All right, so what we've shown is that we used factoring to find the two solutions to this quadratic equation, and then we confirmed that they actually were solutions. Now, even though I am done with this problem, as I said, I'd like to say one more thing about it. Occasionally, you will see the two answers with the word "or" in between them. Now, I don't do this for the rest of the video, but your professor, teacher, textbook, website you're learning from may put the word "or" there, and I wanted to clarify the word "or" in this context in case you run into it. Like I said, you won't see me do it in the rest of the video, but let's talk about the word "or." If a teacher or professor were to say that a solution to a problem were negative 8 or negative 5, you might interpret that to mean that the answer might be negative 8 or the answer might be 5, and that would be logical. But what's interesting about this equation is that negative 8 is a solution and 5 is a solution. So if they're both solutions, why do we use the word "or" sometimes in our final answer? Because it's more of a logical statement. What's being said here is if it is true that x squared plus 3x minus 40 is 0, then it must be true that x is negative 8 or x is 5. And that's the kind of logical construct that surrounds these problems and justifies the word "or." That kind of logic escapes most people, and I don't think you'll ever be asked to reproduce that again, but if you're curious where the word "or" came from, that's why. If you're not, then just put the word "or" in your answer, or depending on your teacher, don't. Most teachers don't care. Here's another problem. So let's do what we did on the last problem and show how it's going to go wrong on this problem, because there's something fundamentally different about this one. So let's cover up the right side and factor, and we'll put the 45s back. And then we will set each of our factors equal to 45. Now, is there such a thing as the 45 product property? If two numbers multiply to make 45, must one of them be 45? Absolutely not. That's ridiculous. So we can't treat this problem like we did the last one, because what was unique about the last problem is it had a 0 on the right, and that 0, this one doesn't, you'll notice, and that 0 made us able to use the zero product property. So if having a 0 on the right side of the equation is that valuable, why don't we make there be a 0 on the right side of the equation by subtracting 45 from both sides? Now that we have a 0 there, it would be useful to factor and then put back the 0. Because now I can apply the zero product property. Again, if a number times a number is 0, then one of those numbers must be equal to 0. In other words, I can split my factored equation because there's a 0 on the right side. Once I've split it, I have two simple linear equations, no big deal, and there's my two answers to this quadratic equation. Let's look at another example. You'll notice here we already have the 0 on the right, so we're ready to factor this side. Notice, however, that this is not a trinomial, and it doesn't factor in the traditional way. It is, however, factorable because we can factor a 2x out of each term in this equation. If this looks unfamiliar to you, check out my previous factoring videos for more details. But assuming your factoring skills are good enough to follow that, I can put my zeros back now and once again apply the zero product property, setting each factor equal to 0 itself, and then just solving each linear equation that results. The equation on the left, 2 times a number equals 0, obviously leads to the solution of 0. And for the equation on the right, I would add 7 to both sides. I didn't show that, but I effectively did that. And then dividing both sides by 3 gives me this. It is possible, of course, to get fraction answers. So there's my two answers to this quadratic equation. Let's look at something much more complex. In fact, technically, this isn't even a quadratic equation. It's a cubic equation because we have an x cubed. But we'll still be able to use the quadratic equation techniques in the zero product property to solve this. Okay, let's begin. This thing in the box is not a 0, and I'd like it to be. Well, if I want that to be a 0, couldn't I just subtract that quantity from both sides? Absolutely, but doing it that way would get a little messy, especially on the left side. So while that wouldn't be wrong, I'm going to advise that you distribute the x through these parentheses to get two separate terms. Now that's not mandatory, but it sure makes the problem easier because now if I want to get a 0 on the right side of the equation, I can subtract the x squared in one step and add the 3x in another. If you're the kind of individual who likes to analyze the details, hit pause. And let's proceed. Now I have a 0 on the right side of my equation. So I'm going to put that out of my mind for a minute and try to use the factoring skills from previous math topics. Well, first you'll notice that there's an x in every term and I can factor an x out as my greatest common factor. But notice further, let me hide this x for a minute, notice further that the trinomial in the parentheses is itself factorable as a monic trinomial. All right, I'm going to put my x back. So now I have the full factorization of the left side of the equation, and of course, in case you forgot, the right side was 0. But look what I have now. I have, looking at the bottom line, I have a number times a number times another number is 0. Basically 3 numbers multiplied together equaling 0. Well, a modified version of the zero product property, common sense would say, if I'm multiplying 3 numbers together and the answer is 0, one of those 3 numbers must be 0. And that allows me to make an equation out of every factor. The first one on the far left side of your screen is already solved. The one in the middle and the right are easy to solve. And what I've shown here is I now have 3 solutions to this cubic equation. You may have noticed the following pattern. My equations with x squared as the highest powered term, or the highest degree, had 2 answers. My cubic equation has 3 answers. And if you go further on in math, you'll start to notice patterns like fourth degree equations have 4 answers and fifth degree equations have 5 answers and so on. That's a topic for another day. Here's the 3 answers to my cubic equation. And that completes the first lesson on quadratic equations.